Hey, welcome. Today we are diving headfirst into something called unified dynamics. It's a pretty radical, maybe even revolutionary idea in physics that's trying to answer some of the absolute biggest questions about reality itself.
I mean, just think about that for a second. What if all the mind-bending complexity, all the forces, all the particles we see, what if it all isn't just a random cosmic lottery? What if it all boils down to the simple, inevitable geometry of just one single fundamental shape?
Now, to really get why that question is so wild, we first have to talk about the biggest, most nagging mystery that sits right at the heart of modern physics.
Okay, so for decades now, our best map of the subatomic world has been what we call the Standard Model. And look, it's been unbelievably successful. It's predicted particles, it's described how they interact with incredible accuracy. But for all of its success, it's not the whole story. It's kind of hiding a pretty big secret. And that secret? It's these 19 numbers. They're often called free parameters. You can think of them as fundamental constants of nature, things like the mass of an electron or the strength of gravity. And here's the catch. The theory can't predict them at all. We have to literally go out, do an experiment to measure them, and then just plug them into the equations by hand.
So what that really means is that our best theory of reality relies on a list of ingredients, but it has no recipe. We know the numbers are right because, well, our experiments work. But we have no clue, no fundamental explanation for why they have the exact values that they do. It's a huge unanswered question.
But what if there's an answer? This brings us to a new and honestly pretty startling idea coming from an independent physicist.
So, working completely outside of the usual university system, a guy named Benjamin Walker Mays has been building this framework he calls unified dynamics. And his approach doesn't start with particles or forces or any of that. Nope. It starts with a much, much simpler question.
And this is the core idea right here. The whole proposal is that the laws of physics, all those constants we have to plug in by hand, they aren't random at all. They are the fixed, calculable, mathematical properties of one single geometric shape.
So what is this master shape, this thing that supposedly rules them all? Well, you might be thinking of some bizarre 10-dimensional object from string theory, but it's not. In fact, it's about the simplest three-dimensional shape you can possibly imagine that actually closes on itself.
It's the tetrahedron, a pyramid with a triangular base. In math, it's called K4, which is just a fancy way of saying it's made of 4 points, or vertices, where every single point is connected directly to every other point. It's the most basic, stable structure you can build in 3D. And that's it. That's the whole thing. 4 points, they're connected by 6 edges, and those edges form 4 triangular faces. It's simplicity itself. But hidden inside this simple shape is a really unique mathematical property. Okay, here's where it gets really cool. At each point, or vertex of the tetrahedron, you have 3 of those triangular faces meeting. Now, if you could just snip one of those points and unfold the faces so they lay flat, you'd notice a gap, a missing angle. For the tetrahedron, and only the tetrahedron, that missing angle is exactly pi. This one unique geometric fact is apparently the key that unlocks everything else.
So, how on earth does one single geometric property, this missing angle of pi, allow a theory to spit out all those mysterious constants of nature? Well, let's take a look. And honestly, brace yourself.
So let's start with something called the weak mixing angle. This is a number that tells us how 2 fundamental forces relate to each other. Now, experiments have measured it to be about 0.2312. Unified dynamics, just from the tetrahedron structure, derives it as the simple fraction 3/13. You plug that into a calculator, you get 0.2308. That's an error of less than 0.2%. Just wow. Okay, how about the strong coupling constant? This is a huge one. It basically sets the strength of the force that glues quarks together inside of protons and neutrons. It literally holds our reality together. The measured value is about 0.118. The formula from the shape is 129 divided by 112 times pi squared. That gives you 0.1167. That is a match of about 1%. And get this, every number in that formula comes directly from just counting the tetrahedron's parts.
Then there's the fine structure constant, probably one of the most famous numbers in all of physics. It governs the strength of electromagnetism. The theory says its inverse is 13 times pi squared, which works out to 128.3. Again, incredibly close. And that number 13, It's just the total number of boundaries on the shape. The 4 points, plus the 6 edges, plus the 4 faces. It's right there in the geometry. But wait, it doesn't just predict forces. One of the biggest puzzles in physics is why particles seem to come in exactly 3 generations, or families. Well, unified dynamics derives this number directly from the symmetries of the tetrahedron. The math just gives you the number 3. It's not an assumption, it's a result.
I mean, just look at this table. Across all these different, seemingly unconnected parts of physics, this framework comes up with formulas that are just shockingly accurate. And let's not forget the most important part. This is all done with 0 knobs to turn, 0 adjustable parameters. It's just the pure math of one shape. So, okay, let's just take a breath for a second. What should we really take away from all this? What are the implications if a theory like this actually holds up? Well, it would mean that the fundamental laws of our universe aren't just some random collection of numbers. Instead, they would be a direct, inevitable consequence of the simplest, most stable way to build a network in 3 dimensions. Physics would, in a way, become a branch of pure geometry. And here's what's so crucial. This isn't just some fun philosophical idea. Unified dynamics makes real, concrete, testable predictions. You can actually prove it wrong. It's a falsifiable scientific theory. If we ever discover a 4th generation of particles, or if our experiments show that the weak mixing angle is nowhere near 313, then the whole framework breaks. And that, right there, is its strength.
And so that leaves us with this one final, absolutely staggering thought. Could it really be that all the rich, beautiful, and sometimes completely baffling complexity of our universe, from giant galaxies all the way down to quantum mechanics, ultimately springs from the simple, elegant, and maybe even inevitable geometry of a single shape? That's the question unified dynamics forces us all to ask.